Hey students, this is lesson 11.6. So we're going to learn how to write and graph equations for inverse variations and to compare direct and inverse variations. For the review here, it says circle the constant term. That would be 7, 5, and actually this one would be negative 11. Okay? And in here, we want to compare and start to learn what an inverse variation is. So go back and look at the definition. It's kind of important here. Definition: inverse variation is a relationship between two quantities where one quantity increases as the other decreases. And if you remember back, direct variation, as one value increases, so does the other value. So, and here's a good example. A student downloads several songs at $2 each. As the number of downloaded songs increases, the total cost increases, and that relationship would be a direct variation. The job of building a patio split evenly among several workers. As the number of workers on the job increases, the workload of each person decreases. This is a relationship called an inverse variation. All right, so we're going to work with some of those. So here's the concept. If an equation of the form x times y equals k, or y equals k divided by x, where k is not equal to 0, is an inverse variation, the constant of variation is k. You can find that by finding the product of x times y for any ordered pair. So if you have a constant product, so in this one, x times y equals 3, that is an inverse variation. This is not. Or if you have some constant divided by x is equal to y, so these two are inverse variation equations, and those two are not. All right, so thinking about that key concept, if we know it's an inverse variation, and since it says it varies inversely, we know it's an inverse variation, then that means we have a constant product. So if we multiply the variables together, we always get a constant. And in this case, we're told that y is 12 when x is 6. So we know that 6 times 12 will always be the same constant. And 6 times 12 is 72. Okay, so the equation is, we have two choices. We can either just say that multiply the variables together and you get 72, or we could say y is equal to 72 divided by x, so the constant divided by x. Either way. All right, I'll let you try that. All right, here's a problem that is an inverse variation. It says, suppose a 2,000-pound weight is placed on a lever 8 feet from the fulcrum. I'm going to draw a little picture of a fulcrum here. And then our distance is 8 feet from here to here. And there's 200 pounds there. Like that. How far from the fulcrum should a 160-pound weight be to balance the lever? So let's put a 160 out here. Well, the relationship here is, let's call this x, an unknown. The relationship here is, and you've probably experienced this by sitting on a teeter-totter, that the further away from the fulcrum you are, the less weight you need to balance it. And so it's an inverse variation. So the product of the weight and the distance has to be equal on both sides to balance the fulcrum. So 200 times 8 has to equal 160 times x. So 1600 has to equal 160 times x, and I can just divide by 160, and I get x is 10. So 10 feet away will give us the balance we need. All right, I'll let you try that. All right, what do these graphs look like when it's an inverse variation? Okay, so I'm just going to pick some values for this equation, 2 divided by x, that will work fairly well for this. I think I'm going to change my scale too a little bit. So let's move this up a little so we can see the whole table. All right, so if x is, well, we know we can divide by 2, no problem, and 1. I'm going to use 1, 2, and 3, and then the next number I think I'll use is 6. And I'm going to change this scale to 1 to thirds. So this is 1, this is 4 thirds, 5 thirds, and this is 2, and same with the negatives. It's -2 there. All right. So if I take 2 divided by 1, I get 2. If I do 2 divided by 2, I get 1. If I do 2 divided by 3, I get 2 thirds. And 2 divided by 6 is 1 third. I'm going to do negative values also. And the ones that I can divide pretty good for the graph I'm using are -1, -2, -3, and -6. 2 divided by -1 is -2. 2 divided by -2 is -1. -2 thirds and -1 third. All right. And if I graph that at 1, I'm up here at 2. At 2, I'm at 1. At 3, I'm at 2 thirds. And at 6, I'm at 1 third. And this will actually curve. And we know that we can never divide by 0, because 0 would be undefined. If I do 2 divided by 0, it's undefined. So we know this graph is going to keep heading up in this direction, but never getting to 0. And we also know it's never going to get to 0 this way, because if you divide something by something, you always get something. Okay, now these negative values, and -1, -2, that'd be way down here. -2, -1, -3, -2 thirds, -6, -1 third. We get a reflection of this across the equation y equals -x. So that's what that graph looks like. All right, I'll let you try that. All right, for concept summary, to recognize direct and inverse variations. For a direct variation, y is directly proportional to x, y varies directly with x, and we're going to have a constant ratio. For inverse variation, y is inversely proportional to x. The product of x times y is a constant in this case. So what we want to do is look at the ratios to determine whether it's inverse variation or direct variation. Look at the ratios and the products. I'll just do that over here. This side we'll do the ratio of y divided by x, and over here we'll do the product, x times y. And if we get a constant product, it's an inverse variation. If we get a constant ratio, then it's a direct variation. So if I do 20 divided by 2, I get 10. 8 divided by 5 is 1.6. 4 divided by 10 is 0.4. You can see there's definitely not a constant ratio there. The product, though, 2 times 20 is 40, 5 times 8 is 40, 10 times 4 is 40. So we're going to say this is an inverse because we have a constant product. And our equation we can either write as x times y equals 40 or y equals 40 divided by x. All right, now in this one, we'll check the ratio. And we'll check the product. And the ratio is 24 divided by 3 is 8, 48 divided by 6 is 8, 96 divided by 12 is 8. We really don't have to check the products, but if you want to, you can see that they won't be the same. We'll get 72, 288, and 1,152. So we have a constant ratio. So we're going to say this is a direct variation. And our equation is y equals our constant times x, so y equals 8 times x. All right, in a situation, I think if we represent this with an equation, that'll be the easiest way for us to tell whether it's a direct variation or not. If we wanted to find the cost, we would have to multiply 25 times the number of days. And since we have a direct variation equation, y equals some constant times x, this one is definitely a direct variation. And in this one, their times and speeds vary in their 200 mile per hour run. So the 200 is the constant distance, and distance equals rate times time. So 200 is equal to rate times time. So here we have a constant product. Rate times time is always equal to 200. So that's an inverse variation. All right, I'll let you try that. And on the lesson check, does a graph of an inverse variation always, sometimes, or never pass through the origin? So an inverse variation is going to be a constant, this should say what will the value k divided by x. Our constant divided by x will always be undefined because you can't divide by 0. Okay, so does the graph of an inverse variation always, sometimes, or never pass through the origin? It never passes through the origin because the value is undefined. All right, that's the lesson. I'll see you tomorrow.